We're going to continue today with section 4.1 about divisibility. Last time we encountered two big kind of categories of things. One category was divisibility rules that talked about what happens when you have numbers that divide or don't divide numbers and you add and subtract them together. There's a whole list of 5 items on that list. We talked a little bit about how those interplay. And then we talked at length about divisibility rules for some very specific numbers. We did 2, 5, and 10 together because they all had to do with the last digit. We did 4 and 8 together because they had to do with the last 2 digits or 3 digits, being divisible by the 4 or the 8. And then we did 3 and 9 together because they talked about adding the sum of the items together, or adding the items together to get their sum and finding out if it's divisible by 3 or 9. And then we had a divisibility rule for 6, and we actually spent probably 10 minutes talking about how the divisibility for 6 works in terms of extending it to other numbers and when it doesn't extend to other numbers. And we had left off on example 3. All right, so moving on in a little bit different direction about divisibility. This question says to answer each of the following without actually performing the division. That's kind of how we've been doing all of these in this section. And then to explain how you did each one. So let me make one comment about the word explain. Explain means use words, all right? I say that because on your test, when you say explain, some of you are explaining using mathematical operations, and that's part of it. I mean, I know that does provide basis for your explanation, but we want words, okay? So this number on part A says I've got 34,051, and we want to know if it is divisible by 15. Does anybody know if that divides by 15 without grabbing your calculator or long dividing out to check? What's that?
17 on the screen.
17 is what I meant. Did I say 15? I'm sorry. 17 is what I mean for sure. 34,051 divided by 17. Will it divide? It's a good guess. I mean, like, percentage-wise, you'd be right? Any other, there's plenty of numbers that aren't going to divide. This one actually will. Yeah, you get a 50-50 shot. Thanks for being bold enough to give it an option. The reason that it will is because of the specific numbers chosen and how they relate to 17. What happens if you double 17?
34.
You get 34. Any idea what happens if you triple 17? You get 51. So the pieces themselves would break apart in such a way that each of the pieces are a divisibility individually by 17. So this does work because 17 divides 34. Remember, we write the number at the beginning of what's divisible, right? It's the divisor for 34. And 17 divides 51. So if I did the break apart algorithm like we had done before back in section 3.5, it would be able to be used right here, and these would divide. If you think along that lines, is 19 going to divide 19,031? No. Why not? Yeah, because 19 divides 19, that part's good, right? So sort of like check mark that off. But 19 does not divide, that's our symbol from last time, the 31. So that one fails. C and D are a little different. Any idea if 2 times 3 times 5 times 7, and I'm not asking you to tell me what is 2 times 3 times 5 times 7, but is 2 times 3 times 5 times 7 divisible by 5? Taryn says yes, and she's right. Do you have a reason, Taryn? You multiply them in your head. I didn't want you to multiply them. You broke the rules. Oh my goodness.
Because there's a 5.
Say that really loud for me, Hannah.
There's a 5.
There is a 5 listed in the factors, right? To be a divisor means that it actually has a factor of 5. And when it's written in factored form, it becomes easier to see what those components are. So yeah, this one works because 5 is a factor of 2 times 3 times 5 times 7. So then, 2 times 3 times 5 times 7 plus 1. Ariel says no. Why not, Ariel?
Because the one before was divisible by 5, but if you added the one before, it just wouldn't.
Right. And there's several ways. You're right. It just wouldn't. So let me give you a couple of different ways to think about it. I can think of 3 that I can describe, so I'll describe all 3 of them. One option's along the lines of what you said. So this piece that I underlined, it's divisible by 5, right? Is the 1 divisible by 5? No. And this one's not. So the answer is no. If I had added 15 at the end, it would work, because 5 would actually divide into both pieces. Okay? Another way to think about it is that this result, 2 times 3 times 5 times 7, it actually must end in a 0. Anybody know how I know it ends in 0 without multiplying it out like Taryn did? Melanie? Okay, good. So that eliminates everything but the 5 and the 0. So why is 5 actually not a possibility? Do you know? Because there's a 2 as well. So there's a 2 and a 5, which would be a 10. There's really a factor of 10 present in there. But even if you got as far as Melanie did and you said it ends in 5 or 0, you'd be okay to continue with what I'm going to say. But this one actually will end in 0. So what happens when I take something that ends in 0 and I add 1 to it? It doesn't end in 0 anymore. You're right. It ends in 1 or 6 if we didn't recognize that there was a 2 in there, right? So it would end in a 1 or a 6. And so that's not going to work to be divisible by 5, right? So it must end in a 0. So 3, 5, 7 plus 1 ends in 1. Thus, it's not divisible by 5. And I kind of combined 2 ways when I described it on the first one. So thinking about in terms of the 2 divisions, or thinking about it in terms of what happens if I had both pieces divided and so forth, are very similar. So this one is no. All right, 24. Now we encountered, actually let me go back to this problem from last time on part C. I mentioned on part C last time that we would have another problem that kind of addressed the same issue. Number C, or letter C, said if a number is divisible by 8, then it's divisible by 2 and 4. Does anybody remember why? Why we could for sure say that that was true? I mean, I gave us a list of numbers and we decided it must be true, but do you remember why we said it must be true? 2 and 4 factors of 8. That's exactly right. So you can always take a number, if it divides something, and break it down into its factors, and all those factors are going to divide it as well. And we can actually do that now with example 4. So if 24 divides a number, what other numbers would divide that same number? Okay, 6 and 4. And I actually really like the way that you said that, Ariel. You sort of like included them in pairs. It's easier to think about them that way, I think. Any other pairs of numbers you can think of? 3 and 8. What else? 12 and 2. And technically you could say 1, right? I mean, 1's always going to work because it's 1 and 24. Did we get them all? I think so. Okay, so now, if I wanted to check and see if something's divisible by 24, which of these could I actually use and know for sure whether they were or were not divisible by 24? Thinking about what we did last time. 3 and 8. Why, Erica?
Because 2 and 4 could both be divided, or 6 and 4 could both be divided by 2.
Right.
And then 2 and 12 could also both be divided by 2.
Right. And 3 and 8 then are the only 2 numbers that don't divide by anything other than 1 when you compare them to each other, right? Yeah. So 3 and 8. So if you wanted to test if something was divisible by 24, you could test 3 and 8, but you couldn't necessarily test the 6 and the 4 or the 2 and the 12 and actually guarantee that was going to work. It's just a throwback to last class period. All right, I mentioned problems like this occurring last time, that you were going to have some examples of this. We have a number partially given. It's 543,220 something. And we want to know what number we could put in the blank so that it's divisible by each one of the following. Okay? So it's the last digit. What number could go in the blank so that this number would end up being divisible by 2? Right? Any even number at the end will make the entire number original, putting that in there, divisible by 2. What would I need to do to decide what number needs to go there to be divisible by 3? Right, I need to add up what I have so far. So 5, 4, 3, 2, and 2. What is that so far? 16. Is 16 divisible by 3? No, it isn't. It isn't divisible by 3. But are there numbers I could add to it that would make a number divisible by 3? What's the first one? A 2 would work. What else? A 5 would work. 5 plus 16 would be 21. What else would work? An 8 would work. And 11 would, but I need a single-digit number. So yeah, so we're done at that point once we extend past our single-digit numbers. And notice that you can actually get from these to the next one. It's an arithmetic sequence, right? You just add 3 more to it. So you're getting an arithmetic sequence here. All right, so 2, 5, and 8, if placed in the last spot, would make this divisible by 3. So using those 2 pieces of information, what number would I need to have in the last spot to make it divisible by 6? Two is a possibility. Any others? And 8. Okay, so why the 2 and the 8? Cassidy and Zion kind of teamed up on that one accidentally.
Because a number has to be, for it to be divisible by 6, it also has to be divisible by 2 and 3.
Mm-hmm.
2 and 8 are the only ones that are divisible by 2 and 3.
You got it. That's perfect. So to be divisible by 6, it's got to be divisible by 2 and 3. And these 2 numbers, namely 2 and 8, are in both of those lists, right? I see it here and here, here and here. Good job. All right, thinking a little bit more about divisibility and going backwards and forwards. Answer the following. Justify your answer. If a number is divisible by 5, can it be divisible by 10? Yes. So the first answer on the can it is yes. Why? We'll answer the why for this now. Why could it be divisible by 10? Because what was that? Because some of them will end in 0. Right. Because some, we'll say multiples. Some multiples of 5. I like the way you guys described that. Some multiples of 5 end in 0. Okay, so yes, it can be. Must it be? No, why not? Yeah, because some multiples of 5 actually end in 5, right? Okay, now, next question, but related. If a number is divisible by 10, can it be divisible by 5? Yes. Why? That's a really good way of describing that. Yeah, because 5 is a factor of 10. If you want to think about it like we did part A, you could say because it ends in a 0, right? If it ends in a 0, it'll be divisible by 5. So you could go that direction in your description. Either of those will work. Must it be? Yes. And it's actually for the same reason. Or, again, whichever of the same reason you want. Do you want the same reason I wrote down or the one that I said? Either way. It has to end in a 0. Everything that ends in 0 is divisible by 5. 5 is a factor, so it absolutely has to work. All right, last example here. This is a funny one. Okay, if we have a number which ends, in which each digit, except potentially 0, occurs exactly 3 times, it will be divisible by 3. For example, 777,555,222, 414,143,313 are both divisible by 3. Okay, so do you see the setup is the first part? I haven't read anything about the question, just the setup. Every number that's listed occurred 3 times. If there were some zeros, they wouldn't necessarily need to. So part A then says, cool. Why? Explain why this works. Any idea? Okay, so I heard Cassidy first, so Cassidy, tell me what you're thinking. True, but why, if you add them all together, will it work? What about this specific arrangement forces that? Because why, Erica? Yeah, it has to do with that. Was that where you were headed to, Erica? Fabulous. Okay, so it has to do with the fact that each of them occur 3 times, right? So what happens when you add a number together 3 times? So let's just use this 3-digit number. 4 plus 4 plus 4. So if I did 4 plus 4 plus 4, you guys say that's 12. Is there a simpler way of doing 4 plus 4 plus 4 that you learn in 3rd grade? It's multiplication, right? This is 4 times 3. And that's what happens with all of these sets of numbers. When they occur 3 times, you end up with that digit times 3. Does that make sense? And then, if you think about it, so I used 4. I don't know why I used 4. Well, we'll use 4 because it's in the second set. And then if I did 1 plus 1 plus 1, this would be 3 times 1, right? And I did 3 plus 3 plus 3, I'd have 3 times 3. And we already talked about a moment ago that when we add these together, if each number if each number that I'm adding is divisible by 3, then their sum is divisible by 3, right? That's exactly why we were saying over here that D didn't work. Each piece was not divisible by 5, just the first piece was. So this works. So let's explain in some words. So far I've shown it in some I want to say numbers, but I was going to say a numerical example, and then it all ran together. So, all right, let me move this over a little bit so some more space. Okay, so what we have is that when a number is added together, three times, you have 3 times the number. I.e., 3 is a factor. Of this. This happens for every number. I would say digit. Every digit. That's better. Every digit in this number, or in these numbers. Thus, each sum divides by 3. So the sum of everything also divides by 3. Some version of that anyway. Part B says, must this statement be true for a number to be divisible by 3? Can you make examples, Zion?
543,222.
That's when we did before, isn't it? 543,222. This was an earlier example. This number was divisible by 3. And the numbers did not occur, all of them, 3 times. The 2 occurred 3 times, but the 5, 4, and 3, of course, didn't. You could create lots of examples. In fact, you could create really small examples like 12. Right? Yeah, 12 works. It's divisible by 3, and it certainly does not have the numbers occurring 3 times.